Hello, welcome to the course Python Programming for Beginners. As part of Matplotlib library, now we will see other topic related to Matplotlib library, axis, scales and ticks. Here, each axis has two or three axis objects representing the x and y axis. These control the scale of the axis, the tick locators and the tick formatters. Additional axes can be attached to display further axis objects. Coming to the scales. In addition to the linear scale, Matplotlib supplies non-linear scales also, such as log scale graphs. Since log scales are used so much, there are also direct methods like log log, semi-log x, semi-log y towards x and y axis. There are a number of scales. Here we set the scales manually. The following program here, manually we set the scale. Let us see. First we have to import matplotlib.pyplot as plt, then import numpy as np, define figure, axis equal to plot.subplots with 1, 2 figure size 5, 2.7 with layout as constraint. Define the sample data sets, data 1, 2, 3, 4 with random number generator with 4, 100. Then define X data. This is make an ordinal for this. np.arange of length of data 1. Then you are defining data 10 power data 1. Now the data is used for another plotting. Here you are defining axis 0 dot plot of X data, comma data. Then axis 1 set underscore y scale log data. Then axis 1 dot plot x data comma data. So defining y scaling as log data. Then let us see plot.show. Here you can see two different plots. You can see the range also. This is x-axis. This is y-axis. The second one x-axis. Second one y-axis. This range is 0 to 100. Here this is 10 power value. We have taken power 10 power minus 3 minus 1 1 3. Here 0 to 100 y values 0 to 100 400 600 and so on. Here you can see these are all ticks of the graph. Let us run this program and check. So manually we set the ticks here. So the scaling also we have defined with our one. On your Python ideally, first we have to import matplotlib. Then import numpy. Then define figure with subplot with constrained layout and size. Define data 1 to 4 with random numbers 4 to 100. Then define X data np.arange with the length of data 1. Then another new data you can define with the 10 power data 1 that you can set to the axis 0 dot plot of X data comma data. Then axis 1 you can use the log data. Here axis 0 means default X axis. Then axis 1 means that is y axis. Then you are doing the plotting data for axis 1, plot of x data of data. Then plot.show. Here you can see this is the output. So like that here manually you have to set the ticks of the plot. Here you can see both are with different ticks are there with our own customized data. That is about scaling. So in this here you can see the scale sets the mapping from data values to spacing along the axis. This happens in both directions and gets combined into a transform, which is the way that MATLAB maps from data coordinates to axis, figure or screen coordinates. Now you can see tick locators and formatters. Each axis has a tick locator and formatter that choose where along the axis objects to put tick marks. A simple interface to this is set_x ticks. The following program demonstrates the use of set_x ticks. Here you can see, as usual, import Matplotlib, import NumPy, define the size of the plot with layout constraint, define data 1 to 4 with random numbers, same. Here defining x data, np.arange of length of data 1. This is same as previous example. Then axis, first axis, x-axis with 0.plot of x data with data 1. Then axis 1, you are taking plot of x data of data 1. Here you are setting x ticks, set_x ticks, axis 1 dot set_x ticks, np.arange of 0, 130. Here the values labeled with 0, then 30, then 60, 90. Alternate labeling we have done. First string, then label number label value, then again string, number label value. These are all manually set x ticks. Then similarly, y ticks, axis 1 of axis 1 dot set underscore y ticks minus 1.5, 0, 1.5. Here you can see here, no need to specify the labels here. Then axis 1 dot set title, manual ticks for our understanding purpose. We made this manual ticks with this data 0.5, 1. Now let us see the output. Plot.show. So the first one is automatic ticks. The second one is manual ticks. Manually, here we have made 0, 30, 60, 90. This was done manually labeled. This is automatically labeled. Here, like that, tick locators and formatters can be done automatically and manually. Let us run this program. Tick locators and formatters. So first, you can define from figure onwards. You can define. Then data 1 to 4, x data, then axis 0.plot with x data 1, then axis 1 with data 1, then define x ticks with our own customized data labeled manually 0, 30, 60, 90. Then for axis 1, set the y-ticks. Here labeling is not required. Y-ticks we have given minus 1.5, 0, 1.5. That y-axis labels. Then labeling it as the title of the plot, manual ticks. Then see the plot.show. That is the graph. The first one is automatic ticks. The second one is manual ticks. In manual, we have done 0, 30, 60, 90. This is labeled. Y ticks we have given minus 1.5, 0, 1.5. Like that, you can do manually and automatically. Tick locators and formatters. Here, different scales can have different locators and formatters. For instance, the log scale above uses log locator and log formatter. Then you can do plotting of dates and strings also. Dates data, strings data also you can do the plotting. Matplotlib can handle plotting arrays of dates and arrays of strings as well as floating point numbers. These get special locators and formatters as appropriate. Let us see first, for example, for dates data, the following example. Plotting dates. Import Matplotlib. Directly we are taking MPL. Then import Matplotlib with pyplot we are using as plt. We are importing numpy, np, defining figure, axis, subplot, figure size with the constraint layout. Here we are defining dates with range, np.arange, np.date times 64. Here you can give the starting date and the ending date. Then the time delta 1 with hour, the format. Whatever the dates range you can give between the date range, those can be plotted. Then taking data with the cumulative sum of the random numbers of the dates, then plot ax.plot of dates comma data, then define concise date formatter stored in CDF that will be available in MPL library, that is directly Matplotlib as MPL. Pyplot separately you have to import. So MPL is the Matplotlib global object. From that, concise data formatter is taken. Here ax.x-axis dot get underscore measure underscore located. Then set that ax.x-axis dot set underscore measure formatter for that CDF dates data. Now plot.show. Here you can see whatever the dates you have given. Here you can see starting to ending range. This can be plotted. Then y-axis whatever you have given. This is the another way of plotting dates. Let us run this program and check the output lively. So plotting dates. So import MPL, Matplotlib as MPL. This we have not done earlier. Import Matplotlib as MPL. This is already there. If you want again, you can do no problem. Pyplot. Then import numpy. Then define figure with size and layout. 5.2.7 layout is constrained. Then define the dates. Here I changed the date. So today's date is 25th December 23. I have taken the range up to 15th January 2024 with format hours. Now taking the cumulative sum of the data with the length of dates that is stored in data. Then you are plotting the dates with this data. Then defining concise data formatter that is stored in CDF mpl.dates.concise date formatter method. Then you are setting set measure formatter of the CDF data. Then you can see the plot. Here you can see I have taken the date as 25th December 2023, 25th, with the range you can see 25th, 29, next January, 5th, 9th, 13th. The end date is 15th. So in between the range. Here 2024 January. So like that you can plot the dates data. Similarly for strings also. For strings also you can give the labeling of your choice. For strings we get categorical plotting. The same program import matplotlib.pyplot as plt, import numpy as np, then figure comma axis equal to plot dot subplots, the same size constraint layout. Here we are taking categories. For example, fruits names are taken mango, apple, grapes, watermelon. We are taking bar chart ax dot bar of. We are taking categories with these np dot random dot rand length of categories each. Here four objects, four artists are there. You can see the plot.show. Here you will get mango, apple, grapes, watermelon with the length of the strings. So categorically, this can be plotted for strings data. Let us run this program. The same here you can take categories, then use the bar chart. Here it is showing error. So here earlier program we used already the data. Again you can define that plot separately. So after that category is already there. Now you can define as problem. Why? Because the figure come axis we use it for earlier program. Again you can reuse that. Then you can use plot.show. Here you can see mango, apple, grapes, watermelon. This is the bar plot type. Here the string data is categorized and labeled categorically. Earlier dates data is categorized. So like that we can plot dates and strings data also. Here there is one limitation about categorical plotting. That is, some methods of parsing text files return a list of strings, even if the strings all represent numbers or dates. Suppose if we pass 1000 strings, Matplotlib will think we mean 1000 categories and will add 1000 ticks to our plot. So that's why this is one of the limitation during categorical plotting in case of text files. Then there are provision of adding additional axis objects. So plotting data of different magnitude in one chart may require an additional y-axis. Such an axis can be created by using twin-axis method to add a new axis with an invisible x-axis and a y-axis position at the right with similar to twinny y. Similarly, we can add a secondary x-axis or secondary y-axis having a different scale than the main axis to represent the data in the different scales or units. Let us see the following program demonstrates the use of adding of additional axis objects. Here import matplotlib, import numpy, define t with random numbers, a range of starting, end value, step value, then s equal to np.cos of with this range, then defining figure ax1, ax3, plotting subplots with 1, 2 figure size. We are taking the different figure size. Length, height is 7, width is 2.7, constant level. Here L1 ax1 dot plot with t, s values. ax2 equal to ax1 dot here using twin x additional axis. L2 equal to ax2 dot plot of t, range of length of t with c1 label. ax2 dot legend we are defining L1, L2. Take a sign left, straight right. We are labeling. Then ax3 dot plot of t, s. Then ax3 dot set x label angle in radius. Then ax4 equal to ax3 dot secondary axis. We are taking top function equal to np dot radius to degree, np dot degree to radius conversion. Then ax4 dot set x label angle in degrees. Now you can see the plotting, plot.show. So this is the first one, this is the second one. In first one, here you can see this straight line right. Then this blue one, sine, left to right. This is the x-axis data. This is the y-axis data. Plot 2, we are defining x label as angle in radius. Then the title is angle in degrees. This is the view. We are defining this is x-axis, this is y-axis, this is additional x-axis. This one 0, 100, 200, 300. Here in this is additional y-axis. 0, 100, 200, 300, 400, 500. In this additional y-axis is there, in this additional x-axis is there. So like that you can add additional axis objects also. Let us run this program. Additional axis objects. First define t, then define s, then define figure, then L1, L1 equal to x1 dot plot of t, s. Then ax2, we are taking twin x as the additional axis. Then L2, defining plotting of ax2. Then we are defining the legend with L1, L2 combination. Then plotting of ax3 with t, s. Then taking the x label ax3 angle in radius. Then ax4 defining top function, secondary x-axis, top, the position is top. Function is radius to degree and degree to radius. Then set the label of that additional axis, angle in degrees. Then see the plot. Yeah, this is the output of this program, what we explained. In first plot, we are having additional y-axis. In second plot, we are having additional x-axis. Here, additional x-axis is also labeled with angle in degrees. Then bottom original axis, angle with radius labeled. Here in first diagram, we labeled the legends, sign left, then straight right. Like that, we can do customization as per our convenient. Okay, that's all about axis, scales, and ticks of Matplotlib. In next upcoming lectures, we will see other interesting topics related to Matplotlib. Till then, stay tuned for latest updates.